The Atlantic Ocean stirs early this year, birthing a storm named Andrea before hurricane season even begins. Andrea isn't just wind and rain, it's a sign of shifting patterns, a symptom of a changing climate. Once storms followed predictable seasons, but now early arrivals like Andrea are becoming more common. The ocean, our planet's thermal battery, is warming faster and earlier, fueling storms in new places and times. Andrea's formation is like a spring flower blooming in winter, a clear signal that the old rules no longer apply. Recent years have seen more out-of-season storms, hinting at a fundamental change in the Atlantic's behavior. The question is no longer if the climate is changing, but how quickly and how much it will reshape our world. Andrea is a prologue, a quiet warning that the boundaries of hurricane season are blurring. Each early storm is a data point, urging us to pay attention to the subtle shifts before more dramatic changes arrive. Understanding Andrea is the first step to grasping the immense forces now at play. The story of this storm is the story of our planet in transition. How does a storm like Andrea form? It starts with the sun heating the ocean, creating a reservoir of warm water. Add a spark, a disturbance in the atmosphere, and the process begins. Warm, moist air rises, cools, and releases heat, fueling the storm. The Earth's rotation gives the system its iconic spin, transforming chaos into a swirling vortex. Without this rotation, we'd have scattered thunderstorms, not organized cyclones. The recipe is simple: warm water, a spark, and planetary spin. Even a subtropical storm like Andrea follows these rules, finding enough warmth and a disturbance to ignite. What's changing is how often and where these ingredients come together. As oceans warm, the conditions for storm formation are spreading and intensifying. Andrea's early arrival is proof that the recipe for hurricanes is now easier to fulfill. Stronger storms aren't speculation. They're physics. Our atmosphere traps more heat, and over 90% of that excess is absorbed by the oceans. Warmer water supercharges hurricanes, letting them intensify faster and grow stronger. Rapid intensification, like Hurricane Michael's leap to Category 5, is becoming more common. A warmer atmosphere also holds more moisture, leading to record-breaking rainfall. Think Hurricane Harvey's deluge over Houston. These aren't just bigger storms, they're different storms, overwhelming infrastructure built for a cooler world. Climate change may not create more storms, but it makes the ones that do form more dangerous. Andrea, though modest, is a product of this new environment, forming earlier and in places once inhospitable. Each storm is evidence that the rules are changing. The future storms are being forged in today's warmer oceans. The impact of these supercharged storms is real, measured in flooded homes, eroded coastlines, and lives upended. Storm surge, now riding on higher seas, pushes farther inland, turning manageable floods into disasters. Hurricane Sandy's surge was amplified by a century of sea level rise, turning a bad flood into a catastrophe. Modern storms unleash more rain than ever, overwhelming defenses built for the past. Andrea may be weak, but it marks the conditions that create monsters. Our interconnected world is vulnerable to these escalating disasters. The story of climate change is unfolding now in every early storm. Understanding these changes is our first step towards securing the future.